Hello, I'm back. Okay, this is for cylinders. This is surface area for cylinders and spheres. Okay, now here's the cylinder we made, right? And we want to get the surface area, the amount of material, the amount of surface area here that we would get on the cylinder. And it's pretty clear that the top and the bottom are both circles. So to find the surface area at the top and the bottom, we would just use the area formula for a circle, right? But what about the curved side? What about the lateral side? What shape is that, and how do we get the area of that? Well, let's see. Let me draw a picture here. Well, no, actually we'll go to here. Here's the net that we used to put it together, right? And here's the top, right, which was a circle. Here's the bottom, which is an identical circle. And then here's the part that we cut out and then curled around like this. Curled around like this to make the curved sides. And that looks a lot like, to me, a rectangle. So to find the area, so this curved side of a cylinder, in fact, is just a rectangle, which is good because we know how to find the area of a rectangle, right? So let's find this shape here. Okay, I'm going to find the dimensions of it here. Okay, which is, if we've got it already cut apart like that, where did I put my ruler down? There it is. Okay, to get the area of the top and the bottom, we need to know the radius. So we don't have the exact center of this marked, but it's about right there. So I'm going to go ahead. I'm going to see here, oh look, that radius is 2.5. So the area of the top is, since it's a circle, pi r squared. So it's pi times, or rather, write it all out here, or rather 3.14 times 2.5 times 2.5, right? And that works out to be 3.14 times 2.5 times 2.5, which is 19.6 rounded off centimeters. The bottom is identical, right? It's also got a radius of 2.5, so its area would also be 19.6. I don't need to calculate that again. Now to get the area of this rectangle here, this cutout, we just measure the length and the width, don't we, right? So this is 10, right? And then this is 15. Looks like that's going to be 16.5, right? Since that's a rectangle, the area of this is 10 times 16.5, which is 165. So now we add, to get the total area, we add the 19.6 plus the 19.6 plus the 165, right? So the total surface area for this cylinder here is going to be 165 plus 19.6 plus 19.6, right? Which works out to be 204.2 square centimeters again, right? And that is for, actually, keep in mind, this constructed cylinder where the radius was 2.5, right? So this guy right here. Now, maybe you're thinking, well, that's cool. When it's all laid out flat like that, I can measure it. I just need to measure that rectangle there. It's cool. But what if it's not laid out flat, which generally won't be? How do I figure out what the side dimensions are? Well, let's just show here. Okay, I'm going to put this aside. Here's another. Put this aside for a second. Here is a little tiny Coke can. Notice it's a cylinder, right? So what I'm going to do is I'm going to take this can, I'm going to cut it apart. Okay, like this. Just and lay it out flat like the other one is. And so roughly speaking, I'm going to go ahead and I'm going to push it in here. I'm going to try not to stab myself. Okay, so I just pushed the can in there. So I'm going to use my scissors here to cut it apart. So this is going to be a little rough, only approximately. So there's the top, right? I kind of tore up the sides of it. All right, and then I'm going to cut down the side here to open it up. I'm going to cut down the side there to open it up. I'm going to slice off the bottom. Kids, don't try this at home. It's a little wet because I washed it out. There's the base, right? See? On here, that's the top and that's the bottom, right? So those are the two circular bases. And then here's the side of it, right? Which is a little bit jagged because I cut it with the scissors. But let's just assume that the sides are just perfectly laser cut, okay? And it was like this, but when I open it out, oh look, yep, roughly speaking, there's the rectangle that we were seeing here, right? There's the rectangle, here's the rectangle, yeah? Okay. So, here's the height, here's the length, or rather, here's the length and there's the width. But if we hadn't cut it apart, because, you know, we're not going to do that. If we hadn't cut it apart, how would we know what this length and what this width is? Well, can you see that before I cut it apart, that this part here, which became the width of the rectangle, this was actually the height of the cylinder, right? And this part up here, which on the cylinder when it's constructed is bent into a circle, is actually the length of that side. Well, what is this in terms of the cylinder? Well, can you see that this is actually the circumference of the circular top? So what becomes the length and the width of the sides is actually the circumference of the circle on the top and the height of the cylinder. Okay? So, hence, here's going to be our handy-dandy formula. It's all wet. For the volume of a cylinder. For the surface area of a cylinder. Now, I cut that all apart and showed that so you can see that when we write this complicated looking formula out, there's a reason for it, right? Okay, so this is going to be surface area of cylinders, right? Here's the cylinder, right? Well, what are we going to know about the cylinder? We're going to know a couple of things about the cylinder. It's really got two important dimensions. One is we're going to know the radius. And the other is we're going to know the height of the cylinder, right? So to get the area of the top and the bottom, the identical top and bottom, we're going to get the area of the top and just multiply it by 2, right? Pi r squared for the top, then times multiply, double it to get the area of the bottom as well. Now, how are we going to get this? Well, we're not going to cut it apart, but remember that when we did cut it apart, here, this was curled around the top, so this length here is actually the circumference of the can. And this is the height of the can. So that means that, and we're going to multiply the length times the width, so it's the circumference of the can, or the cylinder I mean, times the height. It's what gives us the area of the side there. Well, how do we get the circumference? Well, that is still 2 pi r, and then times the height. And that gives us the area of the side. So up here, we add this plus that, gives us this complicated looking formula for the side of the can. So this is the surface area formula for a cylinder. And it's probably about the most complicated formula we're going to have. Okay? So you need to know 2 things. You need to know the radius, and you need to know the height. Okay, does that make sense? Okay, good. Okay, so that's how we get the surface area formula for a cylinder. Now I'm going to stop right here. No, actually, no, I'm not. I'm going to give you the surface area formula for a sphere. And I'm actually just going to put this down on the bottom here because the surface area formula for a sphere is really simple. This one, I'm just going to tell you what the formula is because I can't justify it to you. It takes a certain amount of higher math, just like for the area of a circle, to explain where this formula comes from. But having said that, it's pretty simple. All you need to know about the surface area of a sphere is the radius. And it turns out that the surface area for this sphere is equal to 4 pi r squared. That's it. Okay, that gives you the surface area of the sphere. You may have heard that when you study geography, it's impossible to take the surface of the globe, right, spread it out flat, and make a flat map of the world without distorting the land areas on the top and the bottom, or distorting it somehow. Because it turns out mathematically that, like, although we can take this shape and lay it flat, cut it apart and lay it flat, or we can take this shape and cut it apart and lay it flat, or we can take the pyramid and cut it apart and lay it flat. But a sphere, like a baseball or something, you can't cut that apart and lay it flat and not have it be perfectly flat without distorting it somehow. So that's why it takes a higher math to be able to find out where that formula comes from. But that's okay. So we're just going to have to live with it right now, okay? So that's the formula there. I'm going to provide a list of these surface area formulas just like for you, just like I did for the volume formulas, okay? All right, so that's how that goes. And I'm going to stop this video right now, and the next video will actually work through some examples of the different kinds of shapes. All right, toodaloo.